Welcome back. In section 2.4, we're going to be solving inequalities. And you're going to see here that we can solve inequalities in the same manner in which we solve equations with one slight difference. Okay, so as you can see here, we can substitute an equivalent expression for either side of the inequality. The example I like to use is if we have something like 5 times the quantity x minus 1 is greater than 25, there's our inequality. By using the distributive property, we can make that 5x minus 5 is greater than 25. So all we've done here is replaced 5x, 5 times the quantity x minus 1, with 5x minus 5. Well, we can also add and subtract the same real number from each side of the inequality. So our inequality here, 5x minus 5 is greater than 25. We want to solve for x, so we are going to add 5 to both sides of the inequality, just like we would for both sides of an equation, and we get 5x is greater than 30. Okay. The third thing we can do is we can multiply and divide each side of the inequality by the same positive number. So the rules change for inequalities when it's negative, obviously. If I'm making a big deal, we can only do the same thing with positive. So 5x is greater than 30. We want to solve for x, so 5x is greater than 30. And we divide both sides by 5. Divide by positive 5. And we get x is greater than 6. So there's our solution, that x is greater than 6. Okay. Now the rules here change a little bit. If we multiply or divide each side of the inequality by the same negative number, we have to change the direction of the inequality. Okay, so greater than becomes less than, etc. Okay, so let's use a different example, something pretty easy numbers. If we have negative 3x is less than 12, we can divide both sides by negative 3. However, we have to change the direction of our inequality symbol, so our less than symbol becomes a greater than, and we get x is greater than 4. So that is the only difference, really, when solving an inequality. If you multiply or divide by a negative number, we have to change the direction of the inequality. Or, like you guys say, like to flip the inequality in the opposite direction. Okay. So when we solve combined inequalities, we have a different solution. I think one of our solutions was x is, what did we have? X is greater than negative 4. I think that was our solution. Okay, so that would be the algebraic solution. We would write that particular way. X is greater than negative 4. I don't remember what our last one was. X is less than 6. It may have been greater than 6. We'll make that less than or equal 6. So those are two different algebraic solutions. Okay. If we were doing our interval notation, x is greater than negative 4, so we do parentheses, negative 4 on the low end, and the high end would be positive infinity. Okay? Or if we have x is less than 6, well then we go negative infinity and 6, but we are including 6, so we would use a bracket. So there's an example of the interval notation for both of those. And then we would graph our solution as well. I might ask you to graph that. Okay, x is greater than negative 4, so we put negative 4 on our number line. We're going to do parenthesis. Maybe I'll change my ink color here. You can better see the graph. X is greater than 4. Okay. And then we'll quickly graph X is less than or equal to 6. So I can put arrows on my number line here, so I'll add those to my number line. So my critical point is 6, and we want less than or equal to, so we're going to do a bracket, and then we want to graph everything that's less than 6. So there's our graph with the bracket, less than 6, and here's our graph, parentheses greater than 4. All right, well, thank you very much, and we will see you